Given that sine theta is equals to 5 over 13 and theta is acute, we are asked to find cos theta, tan theta, sec theta, cosec theta, and quot theta. So let's begin by bringing all the parameters we have. So the parameter we have here is we have been given the value for sine theta, which is equals to 5 over 13. And we know that from the modern definition of trigonometric ratio, we have a formula which we stated last week in the last class, which is SOHCAHTOA, where we have sine to be opposite of hypotenuse. So this is sine theta, 5 over 13. So this means that for the 5 to be opposite and that of 13 now is the hypotenuse. That is why we said that sine theta is opposite of hypotenuse. So the opposite is 5 and the hypotenuse is 13. So this question requires to sketch a diagram, which is diagram of a right angle triangle. So let's just make a simple sketch here. This is a right angle triangle. So we have the opposite side, which is 5. So here is 5. We have the hypotenuse, which is 13. So let's label this as A, B, C. So this side BC is the side we do not have, which is the adjacent side. So we have to look for this side. Use what we call the Pythagoras rule. The Pythagoras rule states that the square of the hypotenuse is equal to the square of the that is equal to the sum of the square of the opposite and the adjacent side. Um, I've treated Pythagoras rule in my previous classes before now. So here we have the hypotenuse to be 13 square is equal to the opposite, which is 5 square, plus the adjacent square. Okay, to have so from here, all we need to do is scalar like terms. We have 13 square minus 5 square, which is equal to the square of the adjacent. Okay, so 13 square gives us 169 minus 5 square gives us 25, which is equal to the square of the adjacent. So when we subtract 25 from 169, we're going to have a value of 144 equals to the square of the adjacent. So for us to get the value for the adjacent, all you do is take the square root of both sides. We will take the square root here. The square root will cancel the square here. So we have left with the square root of 144, and we are going to have our answer to be equals to 12. So that means our adjacent side now is going to be 12. So here becomes 12. With this triangle now is a complete is complete, having all the three sides. So with this now we can solve the question. Let's solve the questions that has been given. So we already have sine theta, which is 5 over 13. Let's begin with the first question, which says we should find cos theta. So we all know that from the formula that I stated in the last class, the formula for cos theta is equals to adjacent over hypotenuse. So we are going to substitute in the values and then get our answer. So we have our adjacent now to be 12. So this is 12 over the hypotenuse, which is 13. So the cos theta is 12 over 13. And that's the answer. Now moving on to the next one. The next question says we should find tan theta. So tan theta, the formula is opposite over adjacent. And we have our opposite to be 5 over the adjacent, which is 12. So we can break this to the lowest term because so from this is the final answer, which is 5 over 12. Moving on, the third question is sec theta. And the formula for sec theta is 1 over cos theta is equals to 1 over, we have our cos theta to be 12 over 13. So we just impute the value, which is 12 over 13. So this is the same as saying 1 divided by 12 over 13, which is equals to 1 times 13 over 12. Because when the division sign turns to multiplication, then we take the reciprocal of the what? Of the fraction. So that meaning that the denominator becomes numerator and the numerator becomes denominator. So simplifying this, we have 1 times 13, which is 13 over what? Over 12. So this is our final answer. Moving on, the next question says we should find cosec theta. And cosec theta, the formula is 1 over sine theta. We have 1 over, already we have our sine theta from the question, which is 5 over 13. Okay, and this is the same as saying 1 divided by 5 over 13. This is the same as saying 1 times the division turns to times. Now the numerator becomes the denominator now. The numerator now turns to what? 13, and denominator becomes what? 5. And 1 times 13 gives us 13 all over. Here we have 5 as the final answer, which is 13 over 5. So moving on to the last one, which is cot theta, number 5. We have cot theta, and the formula for cot theta is 1 over tan theta. That is 1 over, already we've calculated tan theta before now, which gave us 5 over 12, and this is 5 over 12. Simplify, we have 1 divided by 5 over 12. This is equals to 1 times 12 over 5, and 1 times 12 gives us 12 all over denominator, which is 5. So cot theta is going to be 12 over 5. So this is as simple as that. As you can see, once you miss out the answer from the beginning, I'm sorry, you might not be able to get the rest of the questions correctly at some point. So we have to be very careful when solving any question on that trigonometric ratio. So this is just the basics of trigonometric ratio. If you have any question, kindly drop your question in the comment section and we shall take it up from there. For watching, viewers, kindly stay tuned as we bring more examples for us to solve under the trigonometric ratio. See you in the next class, and bye for now. I remain your tutor, Aisha Bande.